All right. Well, we just want to thank everybody for coming. I'm going to stay on this screen for a little while, though, just because I know Michael Peterson is still setting up and he's on site there. Um, so we want to give them a little bit more time to get going. But this is not a random picture. The reason I've got it up on the screen is I want you guys to look at it. It's a beautiful town in northern Germany. It's called Blomberg, Germany. And this is where Phoenix Contact is headquartered in this city. So if you look at the picture there, you'll see an intersection that splits off and it goes, the streets go on both sides of the city, reaching off into the hills. All those buildings are Phoenix Contact. That is Phoenix Contact Blomberg. That is our R&D area. That is huge manufacturing facilities. This is our customer outreach center. You'll notice the solar tracking solar panel in the traffic circle there. That is actually supplying power to our all-electric society demonstration village right across the street from it. Might want to mute yourself there, Brad.
I should have, yes. I apologize.
So from Blomberg, Germany, Phoenix Contact has been making automation products for now 101 years. And we don't manufacture just in Germany. We have manufacturing sites in Europe, we have manufacturing sites in Asia, and we have manufacturing in the United States as well. Here in the United States, we are headquartered in Harrisburg, Pennsylvania. And this is typical for Phoenix Contact. Phoenix Contact came to America back in 1980. They bought land, they built their own building, they filled it with Phoenix Contact automation, and then we both make product here and we ship product from here. That is our main US warehouse. So that US warehouse is a fully automated warehouse, automated by Phoenix Contact. So, these are like 7-story robot pick and place warehousing. So it to be honest with you, it reminds me of something out of the Matrix. But the point I'm making is that we build our own products, we use our own products, and we sell our products to the rest of the world. We've been doing it for over 100 years. Phoenix Contact is a privately owned company. We have zero debt. And so major corporations from around the world will come to Phoenix Contact and ask us to build product for them. And we do. Our customers include every big name automation company you can think of out there, and a lot of other major manufacturers from across the globe. So it's a great company to work for. It is a great company to partner with, and it is a great company to start a career with as well. How's Michael doing? Is he in the room yet? I hear no answer.
Nor do I.
That's okay. That's okay. Let's go to the next slide here. This is what I wanted to talk to WSU senior engineering students about. We've done this for several years. We brought you guys in with a PLCNext so that you guys actually have hardware there. The software is something that you can download from the internet when you need to use it. And it is a full programming package. So today, we're going to do a quick recap on what the PLCNext technology is, why it's different, what you can do with it, some of those features. And then I want to go into something that you guys can use as well, because I understand here at WSU, for example, they want to put together a factory floor, a simulation of a factory floor. Every factory has pump controllers in it of one kind or another. So I'm going to show you our PLCNext pump controller, which is both an application that you can download from our web store and hardware as well. The hardware that you have now would be able to run this application. And then, of course, we have ways to get hardware to match it as well. Another application I want to show you quickly today is going to be our PLCNext Gateway app. And of course, finally, I can talk a little bit about our mGuard network security and ways to connect things remotely. The screen is telling me that I'm on hold. Can you guys hear me?
I'm
Okay,
having
everybody can hear me?
difficulty here. I didn't put you on hold, but
All right, that's
try
fine.
and share your screen again.
Oh, didn't realize that happened. There we go.
Yeah, sorry. Some people had tried to be admitted, and I cannot get the admit screen. I hope they just got in.
So let's talk a little bit about what is PLCNext technology. PLC technology is really more than just a piece of software or a piece of hardware. The first image you see on the screen with the brackets, that's our PLCNext hardware. That is what Phoenix we take raw materials and we make finished products with it, and the PLCNext is our latest PLC offering. Next to that, you'll see the PLCNext engineer logo. This is the complete programming software package for that hardware. Now, we don't charge for it. This is something that you can download from the website. You can actually configure and program and test programs without hardware. So it's a really powerful software package. Next to that, you see the PLCNext store. The PLCNext store is where you can go to get the two applications I'm going to talk about today and hundreds more. And then finally, there's the PLCNext community. As an engineer, you can join the PLCNext community and listen to what people are doing with PLCNext, share your ideas with people, talk about ways to do things. You'd be amazed at what's out there globally going on with PLCNext. And I would also encourage anybody to look up PLCNext on YouTube. Phoenix Contact, we have our own videos on YouTube that show the PLCNext. And then we have a lot of people using it as well that put their own videos out. In fact, I'm going to share one of those with you later today. So what is it? It's revolutionary. That's what it is. It's a fully open Linux platform right out of the box. So this is a Linux computer. And as a Linux computer, the Linux is the operating system. Because when I use the word open, what I mean is non-proprietary. I don't mean someone could hack into it or anything. It just means that it's non-proprietary, so you don't have to license the software and you don't have to pay license fees for the rest of your life to use it. At Phoenix Contact, we provide that software, we provide the firmware updates, we provide everything you need to keep going because this is a Linux platform. So our software, the programming software, PLCNext Engineer that I spoke about, operates within the Linux operating system. And in that software, we have embedded HTML5, as well as some other things we'll talk about later. But that's a pretty big deal because it gives the PLC a web server. And because the web server's there, we can actually create HMI screens in the same programming software we use to program the PLC. This means no HMI software, no tags, trading back and forth with a PLC. So it eliminates a lot of programming and a lot of time and hardware as well. To use this, I don't need a touchscreen computer working with my PLCNext. All I need is what we call a web screen, which is basically a monitor with a web browser. So you get a much less expensive screen. In fact, that screen behind me right here, this is a web browser right there talking to a PLCNext. And you can program in all the 61 131-3 programming languages that everybody knows and loves from PLCs years gone by. But in addition to that, too, this one can be used with a lot of different programming languages, things like C++, Java, Python, and much more. So it's a very, very powerful platform. That's the openness. That's what openness means. It means you're not tied to one person's programming software and it's all that will run on this operating system. You can do a lot of different things inside this Linux environment. It's IIoT ready, for example. That means that you can connect this up to a cloud. And PLCs don't normally do that. That's something that's unique and different. And you can do it securely. Again, open source, community driven. There's a lot of applications on our web store. And when you go to the PLCNext community, there's a worldwide group of people out there providing ideas and code that's available to the people of that community. It's a great way to go to market. I mentioned, let Michael in. We need him. You letting him in?
Yep.
All right. PLCNext is secure. And the reason I can say that is because what's going on in today's market is we want secure devices. We don't want more security devices to add. We want the device to be secure. So I'm getting a little feedback there. Okay. So looking at the PLCNext hardware, this is one of our CPUs, comes with a built-in stateful firewall. So right off the bat, this would be our last line of defense. After you got through the enterprise software and then all the way down to the cabinet firewall, now finally down to the PLC, another firewall. So this system is defense in depth. That's what you need to do to have cybersecurity, is to have defense in depth, one, and two, lots of other things like multiple secure logins. If you log out and log back in, it goes right to the least amount of privileges automatically. So it can't be left open at a higher level. And these are all things that are put together by the ISA 99 specification, which is, correct me if I'm wrong, Brad, but I think that's over 10 years old now. And that information went to Europe, and Europe's TUV group actually codified it into the IEC 62443 standard. And that's what our products meet today. Someday, all PLCs will meet this standard. Right now, we're the only one on the market. If you're using some other type of PLC, you're going to have to add security devices around it to do what you need to do. But this will do it right from the start. Trying to get my screen to change, and it's not doing it. There it is. I like this slide because this gives you a good visual representation of what a PLCNext running Linux is. The large light blue box here that you're seeing, that is Open Linux. That is the operating system that is holding everything together. And inside that, Phoenix Contact's PLCNext Engineer is a runtime piece of software that allows us to do our ladder logic and our function block and our structured text and all those 61131-3 languages that we know and love from the past are all happening there. And in it, it's a deterministic PLC. So depending on the size and the amount of processing strength you get, you can put together tasks, multiple tasks, you can run them simultaneously, and you can run them deterministically so that they happen at the same time, in the same amount of time, at the right time, all the time. It's a big deal in industrial PLCs. But in addition to that, there's more in this box, right? Once we get outside of the runtime, go back up to the top. That's where we see the MS Visual Studio, Eclipse, C, C++. You can write programs in any of those, bring them down, create tasks, and run them in the same PLC right next to a ladder logic program or within a ladder logic program. And then all those systems go down and you get output functions across the bottom. And then if you look at the right side of the big light blue box, this is where you're going to see the Docker containers. A container, period, is a way that the industrial Internet of Things gathers up a lot of data and places it in the cloud in a very efficient manner, which allows the cloud to then break it out into dashboards and take information and do other things with it. And that's something that you just never had from a PLC before. Your PLC had to go to a computer, and that computer had to have a lot of software on it, and it had to do a lot of other things in order to get to the cloud. It's not the case. That's what makes us so revolutionary, and that's just one thing that makes it so revolutionary. Let's go on. Let's talk now. Now that you know a little bit about the PLCNext and what it can do, let's talk about pump control, for example. Like I said, if you guys are going to build like a test factory type situation at any college, in that factory, there are going to be pumps. Pumps doing something. In every application, there's pumps. I do a lot of work in the water industry, and that's foundational in the water industry. But they vary a lot. Every pump controller is a little bit different as to what it's doing and how it does it and how many other pumps are working with it. And there's a lot goes on in the pumping market. And on one side, you can get a very simple pump controller built into one box. It has an LCD screen on it, and you go through the buttons and you program it, and you put it in an enclosure, and it's a pump controller, and that's all it does. It's pretty easy to set up. It's one part number to buy, so that makes it an easy thing to do. But it's kind of limited as to what you can do with it. It does its job, and probably does it pretty well. But if you wanted to upgrade it, if you wanted to add I/O to it, if you wanted to connect SCADA to it, not very friendly. Not very friendly at all. So when you're done with it, it's rip and replace. Now, on the other side, the other end of that, you can take a general purpose PLC and you can program it yourself. Now, down the road, somebody else is going to have to maintain it, so that's an issue. But you can have whatever features and functions you want because it's a wide open palette at that point. You can program anything you want in it. And then, of course, support, that's always going to come up. 5-10 years later, Joe, the programmer, has left, and now somebody else is maintaining this. Migration can be a little bit easier because now you're working with a PLC. You can add I/O, you can take I/O off, you can change things, you can add networks. So that's a good thing about using PLC. But there's really, as far as the whole solution goes, it's a DIY, right? Do it yourself. So really, what the market did is it came to Phoenix Contact. A lot of companies came to us and said, we really need something that is like more in the middle, something in that sweet spot, something that I don't have to program, off-the-shelf components, IIoT ready, but I might want to customize it, so I need something that's flexible as well. We delivered. It's the PLCNext pump controller. And so what you're looking at here is a PLCNext and some I/O. Remember I said it had the web server in it? And in the web server, you can also create your screens to go along with it. This is what the pump controller screen, one of the pump controller screens, looks like. So if I were to go to the web and buy my pump controller app on an SD card, plug it into this setup with the right I/O, boom, instant pump controller. It's IIoT ready right out of the box. You don't have to program it, you have to configure it. And by configuring it, what I mean is that you log into the CPU, bring up the web screen, the EHMI, and then configure it, with a mouse, point and click. I'm going to show you these screens later, but I'd like to say that this really is a future-proof and secure pump controller that can be used in any industry, customizable for 80-90% of the applications out there.
Hey, Mark?
Yes, sir.
Let me break in. I got a text from Michael saying our mics aren't working on our end. He's sending you text messages with questions as they come up. And I'll ask Michael, might you put the messages into the Teams chat? And
I do see some messages from Michael. He says he can hear us, so I take that as a good sign. Let's see there is a question out there. How high of a safety level that it meets? When we're talking about safety, we're talking, SIL 1, SIL 2, and it's more than just this unit. It would be the entire pumping assembly and everything that it's connected to. So that said, you can put PLCNext into SIL applications, but you have to look at the whole application. You can't just look at the pump controller alone. And if you have an application we'd love to learn more about it and to come up with something that does meet your requirements. This, the pump controller here, this is not an explosion-proof device, for example, so this would need to be in a safe area because safety has a lot of different things. I mean, SIL, if we're talking about explosion-proof stuff, and yet there's also machine safety and all these other parts of that world. So good question, just it would be a really big answer. Let's see, any other question? How high last meeting? Okay, we're caught up on questions for the moment. So looking at the hardware, you know, all you really need is a PLC and the IO in the program. We're also showing you a web screen. If you didn't have a web screen though, all you need to do is connect to this with a laptop. In fact, I'm going to do that later on in the show, and I'll put the screens up here for you. So no screen development necessary. And because, you know, once again, secure, multiple password levels are there. So in this particular pump controller, we have 3 levels of access. That would be the operator, the technician, and the engineer. Engineer has full configuration. It can actually force IO and test things. And it's all visible on any HTML5 device, which means any HTML5 device, which is an iPad or a touchscreen or your phone or, you know, Android, Apple, doesn't matter, HTML5. Here's some of the screens. That's an alarm screen. This is a configuration screen. This is a vessel configuration screen. You see how big, what we're going to do. Here's where you set your pumps up to be VFD or not. Here you could add energy monitoring to it if you needed to know how much electricity your pumps are using. And finally, this is the actual simulation screen that the engineer login gets. And you can see all those are IO points. You can actually force those IO points and, you know, D1, make sure that, you know, pump 1 is running, it's going the right direction. So it's a really nice debug screen. We call it a simulator though, the simulation screen. Here's an iPad, for example, connected probably on a Wi-Fi network. So if I added a Wi-Fi switch to any PLC pump controller in a panel, now you could walk up to the panel with the proper permissions. You could log into the pump controller and see what's going on. Or it could be on a network and you could be on a SCADA system, or you could be getting data from a cloud. You could be looking at a cloud dashboard. Very, very powerful device. It is SCADA ready. In a lot of worlds, they don't need the Wi-Fi. They don't need the cloud. They don't need any of the IoT capabilities that this product can offer. But they do have SCADA. And what SCADA is the ability to see what's going on in the field, bring that information back to a main headquarters and show it on a screen. So primarily what we see in the industry is Ethernet IP. We see Modbus TCP. We see Profinet, for example. Standard networks from standard industrial control companies like Siemens and Rockwell and Schneider, and, you know, products that you're going to see throughout your career. This is SCADA ready. So if that's what a customer needs and he's putting a pump controller in, it's ready to do that. And then years later, when they want to start doing energy monitoring on the cloud, it's ready for that too. So right now we're actually approved by Amazon. Several of our products are approved by Amazon in order to have their programs listed, and we're up in the Azure cloud. But we can go on to any cloud. In fact, customers can put up their own what we call on-premises clouds. And that's a way to kind of control all your data and all your servers and everything together. You don't have to go to a big company, but it'd be a big company that probably has their own cloud. That's a big time. I'm going to stop on that because you could really go all day talking about clouds. So kind of, you know, to bring it back to you, there's really 2 different ways to do this pump controller. There's a standard one you can get from our web store. We call it the PPC 2.0 level control. Whether you're pumping up or pumping down, it's a level control app. It's $97. You can download it from our website. The PPC application version 3, on the other hand, we work with our value-added partners with that one because it just can do so much more. That's where you can get into pressure, flow, constant level control. So the configuration can get a little bit deeper. So in that case, we would like end user customers to work with a systems integrator, an engineering firm, somebody that would help them. Or if they have the people to train, then they can train up and do that themselves too. But typically, when it comes to a more complex application, a good way to do it is with a Phoenix Contact value-added reseller, of which there are many. We work with so many different companies across the country. This is a difference between the 2 and the 3, version 2, version 3. Level control, I'm doing PPC 2.0. But you notice the 3.0 does everything and more. And if you had a 2.0 and you wanted to upgrade, no problem. It's an easy change for us, and it would cost nothing to the customer at that point. But we want to make sure they've got the capability to implement it. This
And the
is what
PPC is a pump controller. And
yes,
so version
PLCNext pump controller, the
Yeah.
PPC.
Yeah. And so that the version 3 is since this hardware was donated 4 years ago now, I think the RICHL, I would put to the vote of the board, executive board of RICHL section, that we could donate the pump controller card to go with this. And I will put a motion to the board also to buy a second piece of hardware that we can raffle somehow, figure out. We can't buy 12 for each one of the 12 student chapters, but we'll donate, figure out some way to donate it to one of the 12. And perhaps we'll try and get some industry partners in the section so we can buy more than one. So
that'd be pretty exciting.
That's the option. Since we have you other institutions, we could donate as many as we can afford to you other colleges.
And meanwhile, for WSU, you've got some hardware and some IO right now. And I think you could actually just, with the program alone, you could actually have a working pump controller. Pop that SD card out, and you could use that PLCNext for anything else. So it is a very versatile piece of equipment. Pay attention to your IO and what you need to do with it, but it's from the CPU and the program side, it's really versatile. What I'm showing you right now is actually our web store. So if you went to Phoenix Contact PLCNext web store, and then you notice on the left-hand side, we've actually filtered it down to water and wastewater applications. And then when you look there, there's a lot of things we do in water on this particular device, but there's the PLCNext pump controller for level. And it's showing a list price of $97. So you'd go online, you'd put a credit card in, $97, you could download it to your PLC.
And that's app version 3?
No, this is version 2. This is version 2. This is level control. And that's a great place to start, because from there, I mean, all the features, really are there to get it up and running and configure it, make changes, and, do some neat stuff. Do some connectivity, some SCADA applications with it. These are the kinds of things that you're going to do in factories, and you could do it on your test bench. So now once you found it, you went to wastewater, you saw it, you clicked on it. Now I'm looking at it. This is the actual pump controller level here. It's version 2.0. You can see the install. You can see the download button. You can see the price. And notice too, we even have a 10-day free trial. So it'll wipe out your configuration every 10 days, but you could actually do a 10-day free trial on it. Now say though, like what you're saying, Brad, I want to go to 3. I want to do some cool stuff. I need this feature. I need that feature. Well, it can be customized. You can do some really cool things. You have to contact the developer. Who's that? That's us, Phoenix Contact. We're right here. We have guys working on this, and if we need to incorporate something to make your application work better, we want to offer that to you. And if it's a really good idea, we're going to incorporate it into the pump controller for everybody. So it's nice. You're working with a developer that made the hardware, the software, everything. It's one person, one company. I'm sorry. As you dip further into the web store and into the program, this is something that, say you were working in some facility for some company and they wanted to buy a pump controller and they gave you the job to go research one out, get me the information on something we need. You've gone to Phoenix Contact, you've been through the web store, you're like, well, I'm going to need to give some information to my managers of what this thing is. Or if you're going to specify something, I need to do submittals and I'm going to need to know what parts are involved. I need to know where it's coming from. I need, images of what we're going to be using. It's all here on the website. So every single part of this is you can download the information on it, look at the cut sheets, do your submittals, show the boss, make sure that, they understand that this is not some fly-by-night organization. This is Phoenix Contact, 100-year-old company and solid partner to work with. So from a pump control standpoint, the PLCNext hardware can immediately be converted to be a very nice pump controller, and it can do a lot of things. But say you're in a facility now and it's up and running and everything's going good. The only thing is, we just wish we could tie together, a couple of disparate locations and get some information on them. And we want to use a cloud to do that. PLCNext web store, there's an app for that. And it's called the PLCNext Edge Gateway. So once again, just like the pump controller, it's a downloadable app that'll take the CPU and change it into a gateway to a cloud. What kind of cloud? Well, that's pretty wide open. Because once again, being an open Linux processor, there's a whole lot of things that you have access to when you go IIoT. For instance, maybe you don't want to use Phoenix Contact programming software. Maybe your company programs with Codesys. Codesys can run here, no problem. Maybe you're going to go put it on a dashboard up in a cloud and make it available to 2 or 3 different locations. Grafana is a great way to do that. MySQL is used in many, many different applications, and this can be connected right into a MySQL application. We talked about how you can program it in so many different languages and so many different ways. On our larger PLCs, you can actually put Ignition Edge on them and run. So you have a PLC running basically a computer program from Ignition called Ignition Edge that takes raw data from the I/O on the PLC, turns it into real information, and puts it up on the cloud. And this is all happening on the edge. So that's a really cool feature that you can do with it. OPC UA is a very, very highly secure industrial system that is getting bigger and bigger all the time. OPC UA works here. We talked about HTML5 and why that's a great thing. So there's a whole lot going on in containers, Docker containers, all those kinds of things to get up on the web and do amazing things. Now what I'm going to do, if I don't get lost in the sharings, I'm going to share with you. This is a friend of Phoenix. So it's NEF is the name of the company, and they've got a quick 4-minute video of using a PLCNext Edge Gateway to take Allen Bradley Ethernet IP data and get it up to the cloud. So I'm going to stop sharing and then I'm going to come right back in with a different share. Hang with me here. Hang with me. Here we go. Can you guys, I want to use share the sound. There we go. Can you hear it?
75 billion. That's the number of connected IoT devices by 2025. 50% of all IoT platforms focus on industrial and manufacturing industries. So the plant floor is going to see a massive increase in the number of automation devices sending data to the cloud in the future. The PLCNext Edge Gateway is a state-of-the-art IoT and edge computing solution designed for data collection in the most demanding environments. Whether you have a small machine or an entire manufacturing floor, the PLCNext Edge Gateway leverages its advanced industrial design and programming openness to collect data from any device or sensor and send it directly to the cloud. At its backbone, it's doing this with MQTT. And we love MQTT as an IoT protocol really for 3 reasons. It's lightweight and designed for unreliable networks. It's open and has 3 levels of QoS baked right inside the protocol. These features make it an excellent option for sending a high volume of data to analytic platforms and cloud solutions. Let's take a look at configuring MTT communication in the Edge Gateway from PLCNext. In this demo, we're connected to an Allen Bradley Compact Logix and an entry-level PLCNext 1152 controller from Phoenix Contact that's running the new Edge Gateway software. The Edge Gateway allows us to easily push our PLC data to the cloud or publish data via MQTT. We do this with a configurable web page, not programming. For this demo, we'll publish data via MQTT, but also review cloud connection options. Let's get started. So in RS Links, we have our Compact Logix and PLCNext 1152 connected here on our local network. As you can see, we're online with our Compact Logix for this demo and interested in reading this test EIP tag into our PLCNext Edge Gateway. We're going to show how easy it is to pull PLC tags over Ethernet IP. This is the PLCNext Edge Gateway user interface. As you can see, I'm just on a browser and typed in the IP address of the PLCNext. Here we have 3 main windows: drivers to pull PLC tags and publish MQTT tags, cloud connections, and metrics. Let's check the IP address for the Compact Logix. First off, we're going to add our Compact Logix. We simply click New Driver, Ethernet IP, and it will ask us to name the device and enter the IP address. That's it. Once we submit, we'll get confirmation we're connected. If we want extra verification we're connected, the PLCNext hardware config and serial number are also displayed. Now let's add our example tag. We can click Add and type in the tag name. Boom, done. We get instant feedback on the tag value, and we'll toggle it to 10 just to see it update in the Edge Gateway. Now we'll set up the MQTT driver to publish tags. In this example, we're using Ignition as the SCADA system, and our PLCNext controller will become the Edge node. Again, we simply click New Driver, then MQTT, and we'll verify the Ignition address. Port number is set to default Ignition MQTT engine port. Type in username and password for authentication and click Submit. Once again, we get a confirmation that we have a successful connection. But before we publish those tags, I want to quickly go over cloud options and metrics. So we have plugins on the Edge Gateway for AWS, Azure, Google IoT, and Phoenix Contact's Profi Cloud for widget dashboarding. Metrics allow us to scale tags we bring into the PLCNext Edge Gateway and even create logic with the tags that we bring into the gateway. Now let's publish some tags. We hit New Metric, and here we can browse tags and values that are available to us. And here's what's really cool about the Edge Gateway. We can access physical I/O on the controller. For example, vibration or temperature for condition monitoring initiatives. And then we can log that data without ever going into the PLC to have to pull that tag. So say I have a temperature value I want to log. I can access that value, scale it, and log it all in the PLCNext Edge Gateway. So obviously we can publish our Ethernet IP tags, but for this demo, we show publishing of physical I/O. Once we hit submit, we can check our tags in Ignition, and boom, it's already there. Did you look at that? Seamless. Thanks for watching. Reach out to Neff and our team of automation specialists to see how we can help on your next project.
Gotta love those guys. Let me see if I can turn the noise off. So let me go back to my share.
Had any more questions come in from the class?
Yeah, I think I need to leave in a bit, but could you provide your contact information, Mark? So I'm from the University of Idaho, Deb Shrestha, and we are in the process of making this process control, and I would like to talk to you sometime, if possible. Can you hear me? No? Yes?
Mark, could you hear him?
There's another presentation going on here.
Can you hear me now or
hear
no?
this?
No, not the presentation. We can hear you.
Well, Dev, I will send Mark's contacts to you. Now you're muted, Dev. Unmute yourself.
Yeah. I'm now unmuted. That would be great if you could send Mark's email and maybe we can talk a little off this meeting. I don't want to distract from what you want. I'll need to leave in 5 minutes, but it'd be great if you could send his contact information.
And maybe Michael, I'll send you the contacts for Michael Peterson, who's in Coeur d'Alene.
Sounds great.
So.
Thank you, Brad.
Mark, you're mute. Mark, you're muted. Or no, you're not.
I'm not muted, but there's another presentation that's going on top of our presentation, and I don't understand how it got in here. It's Sharista, Deb Sharista. Is he on your participant list?
Yeah, but you're not sharing it. Dev's not sharing a screen, right? Michael, are you sharing your screen? Is Michael sharing his screen with the class?
There, it's gone now. Can you guys hear me?
I can hear you.
Oh,
but I
yeah.
still see. Yeah.
Well, if Michael's there, I'd like for him to talk a little bit about Phoenix Contact and our internship program. Is Michael there? Can he talk about that?
He sent me a text saying no, that he was not sharing a screen.
We're good.
So, Michael is texting something to me. I guess said no, he can't. He can't speak because his microphone's not working.
But if he can see that screen, then I want him to talk to the kids in the class about that screen. So have Michael tell us when he's done, and I'm going to share the actual pump controller. He says he's doing that right now. And for those of you online who weren't aware of this, Phoenix Contact does an apprenticeship program. It is not an internship. It is a fully paid salaried position where we take college graduates, put them through 12 to 18 months training throughout all the phases of our company. And then if they want to work for Phoenix Contact, they can pick the type of job they want, or they can go on and work for somebody else. It is a really great training opportunity coming right out of college. We take apprentices either in January or June, whenever you're ready, and you can find it on the Phoenix Contact website. So it's a really, really good program. We have interns that are now in management positions and senior management positions at Phoenix Contact, and we love to promote from within.
And the internship is while they're a student. Yes or no?
No, this is when you graduate. It's not an internship. This is an apprenticeship. So you graduate from college, you're looking for a job, Phoenix Contact will hire you, pay you. In fact, we'll house you and feed you too for 12 to 18 months. And then you can work for Phoenix Contact or you can go on and work for somebody else. It is an apprenticeship program.
Do you hire students as a co-op? Do you hire students as a co-op also?
No, we hire them as apprentices. They are employees with benefits, 401k, medical, everything. And it's a step into Phoenix Contact where they can get hands-on experience for a good year. And then they can go into any job role that is open to them. Sometimes they go into marketing. Sometimes they go into sales. Sometimes they go into engineering. Sometimes they go into R&D. All of that happens here in the United States. So it's a really, really cool program.
Okay.
And yeah, Michael could hear that second presentation. I don't know where that was coming from. Now, what I'm going to do is I'm going to go back to Teams here, and I want to share the actual connection that I'm on. I'm right now connected to a PLCNext pump controller. So what I want to share is this. So this is a running pump controller that's right behind me here. This little guy in the box. And what you can see is the operator screen that would be visible well, actually, I'm logged in as an engineer. If you were an operator and you only had minimal rights, all you'd see would be the overview and the alarm screen. And what this is showing us is that we have 3 pumps running. Let's move this over here. We have 3 pumps running, and pump 3 is going to turn on next. You can see this is our tank level over here, and it's about to go to high. So we could start getting alarms. Speaking of alarms, this is the alarm screen. If we had them, they'd be here. We could acknowledge them. We could look at historical alarms. We could reset them. Now I've gone to the settings. Now, when I was doing my presentation, these screens went by really, really fast. So let's go through them a little bit slower. First off, I'm connected to the IP address of this pump controller using the web browser on my computer. And that's how I'm getting these screens that are already made for this pump controller. So anybody that buys a pump controller program has all these screens, okay? Nobody has to create anything. So right here, you name it. Mine's named Demo V4. Yours could be WSU pump controller. In some critical applications, people like to deploy 2 pump controllers in case one dies. So that's why we have the redundancy backup system, so they can hand off control from one to the other. Now we're looking at the station tab. Now here you can configure this pump controller application to have 1 to 4 pumps. Ours had 4 pumps. Remember though, there's only 1 vessel. So if we're using 4 pumps, it's probably a very large vessel. Now, between pumps turning on, there's a big inrush of power when a pump turns on. We might want to add some delay there. So here I've got a 10-second delay between pumps starting. The application that we're running is pump down. So it could be a pump up or a pump down with the PPC 2.0. When it comes to using multiple pumps, you might want them to rotate. You might want them to be fixed. Maybe you want them to go with whoever start the next one with the lowest amount of runtime so that we balance our hours on the pumps. All that is available right there. In this case, we're doing a speed control that's linear, but that's because we're using VFDs. So once you've figured out how many pumps you got and what you're going to do with them, let's talk about what we're actually going to pump down. In this case, we've got our shape is cylindrical, it has a diameter of 10 feet and a height of 20 feet. And then you'll notice that is scaled out immediately for us on the vessel right in the next window. We can use different kinds of sensors or floats to get our levels. It's a very flexible device. Sometimes people use both because they want redundant floats. 1 pump controller, but maybe I want redundant floats down there in the well. Gonna move, all right, put that right over there. That's good. And then let's talk about the pumps themselves. Well, in this case, we've got 4. If I'd only selected 1 back on the first page, it'd only be 1 pump here. These are all set to run as VFDs, and you can see that their speed settings are being displayed there. We also have the ability to put a lot of information into this system. So pump 1, we can put the model type, serial number, date it was put in there. All that information could be there and would be available to maintenance guys down the road. When we're talking about stages, this is where our floats are. We want our low, our high, high. And so we set those according to our tank heights. And then we talk about when we say sensors here, what we're talking about is you could add an energy meter. We make EM Pro energy meters, And this particular program, the pump controller program, is set up to receive them. So if we were to add one, put its IP address in here, it would configure itself for the pump controller. Pretty powerful option there. Now we're looking at the I/O. What it's doing. So over here, you can see here's digital 1, here's digital 2. We've got our analog inputs, we've got our analog outputs. So everything we need to see about our I/O is there. And then when it comes to alarms, you have choices of, in this case, all the alarms have been selected. But you could look only for power alarms or pump starts or pump faults, depending on your application. And then as an engineer, you have the ability to get to the simulation page. And on here, this is where we can actually force I/O. So you'll see that there is I/O here that is green and it's being used. So as an engineer, you can test things, make sure that you wire the system up, you test it, make sure everything's looking good. So back to the overview. These are the screens that do not need to be programmed, only configured. I hope that by going through that, what I've showed you is how really easy it is to configure this. So if you guys were to set up a pump controller in your plant floor demo there at WSU, you could put this pump controller online pretty quick. And then what I would do is I would take data from this and I would use that data to do something with it, to create some screens on that. And that could be a pretty interesting project. It really could. So I'm going to stop sharing right now and be glad to throw this back to Brad. Anybody got any questions out there? Oh, Michael says he is talking right now and that they are good. Always before we've been able to be live in the classroom. So this presentation has been a little strange, knowing that they can see it, but we can't actually hear them. But I'm glad Michael is there. Thank you very much, Michael. Michael works in the Spokane area, lives in the Spokane area, so he traveled down for today to be there on site. And I know he's also there with one of our distributors from Stoneway. So I'm glad that they're there supporting the people on the ground. And I want to thank him. And I want to thank Brad Carlberg, too, for setting this up. And Barbara for being here and for training all these engineers that are about to go out in the world. I would ask, though, that the classroom, they do a sign-up sheet. We'd love to gather the names, and then down the road on LinkedIn and places, we want to see these kids out there in the market doing things as engineers, and they're part of the Phoenix Contact family as far as we're concerned. So we'd love for them to reach out to Phoenix and be part of the crowd. Reading a chat here. Oh, University of Idaho.
Let me ask Sandan, SL, where are you from? I don't recognize the name. Take yourself off mute, Sandran.
Oh, my apologies. I'm one of Barb's students.
Okay, good. So, okay. And Delvin from Walla Walla University, would you like to talk? Would you like to schedule a time to get Michael Peterson to come down to Walla Walla?
Yeah, we can think about that. My students are still gone on summer session and will be for a while. So
yeah. So yes, Central and Eastern start on like the 25th of September. Your students start about then as well, or?
September 30 is our first day.
Okay. So yeah. Well, Sandran, thank you for logging in yourself. I I asked Barb to have all the students in class log in. So try and use this. You could use this. This PLCNext has been called the future of industrial automation by the ARC Advisory Board. You can go up on the Richland section website and look at that recording that that is up in the library. But I had talked with Don Bartusiak, who founded the Open Process Automation Forum, of which Phoenix Contact is a member, and asking them for if he had any ideas, and we could get an open process automation forum to he could work with me to flesh a project out.
You know, a lot of these students might not know what open process means, Brad.
Yeah, Sandran, look for the Open Process Automation Forum. Just Google it, and you'll see they have open process automation standards associated with that. And they're a group. They were formed by ExxonMobil because they had probably a couple $1 billion worth of legacy control systems, distributed controllers, distributed control systems, and PLCs that needed to be replaced. And they did not want, Exxon did not want to be at the beck and call of the vendors held hostage. They wanted an open system. So, and that's what they are in the process of doing. Replacing their legacy control systems with open architecture. Are you electrical, Sandran?
Yes, I am focusing on a power.
Yeah, I was talking to her yesterday about she only had the majority of the students were power. Only four of the students were automation. But I thought that you probably know Schweitzer Engineering Lab, and if you do any work with protective relays on the power side, but an edge device like PLCNext can communicate with any devices.
That's true. In fact, our power group actually does have applications for PLCNext in the power market, and we're into substations. Yeah. We do a lot of different things in that market. I happen to be an infrastructure guy, so I work with rail, transit, and water. But my colleague Jim Potter is a power engineer, and he works with Bonneville, and he works with PG&E, and he works with Edison, Sun, and all the other guys here. Salt River project in Arizona is a really big project for Phoenix Contact. They're using PLCNext there as well. So yeah, we're very much in the power industry. I mean, what I showed you here today, all these products transfer right in there. In fact, Goose Messaging, I forget the IEC 61 that the power guys love so much.
DNP?
DMP as well.
Okay.
But 61158 or something, it's the messaging standard for the electric power industry. We have IO and controls that sit right on those networks as well natively. So Phoenix, we're $3+ billion per year sales every year for Phoenix globally. So we're pretty much in every market. But here in the Northwest, we want to get some of these engineers to come to Phoenix Contact to learn our products and go back and work in the Northwest. I think that would be a great thing. And if we can make that happen by working with the colleges out here, then we certainly want to try.
I was going to say, if I could see the youth, I did a little bit of internship out in the 200 West area at Hanford, which was groundwater. And surprisingly, you wouldn't think it, but almost all the electrical engineers were power based, and they were also in control of the ladder logic for all the pump controls and a few other little systems, because the main focus out there is cleaning up groundwater that has been contaminated with either radiation or heavy metals from over the years of the Hanford project.
And it will be going on for many, many years.
Yeah.
And ladder logic is the least applicable programming languages. You can be a lot more concise with structured text than or function blocks if you have analogs, sequential function charts, or even at the Linux level, because it's all compiled. All of the five programming languages get compiled down to the Linux level, right, Mark?
Right, and they all get
Yeah,
and they all get executed together
Yeah, and so
deterministically.
yeah, so
Yeah, no, Hanford just has a problem of having the ancient systems and having a hard time updating them, because once the facilities are built, it takes forever to get approval to move to the next generation. They're working with stuff that's still, well, some of the newest stuff in Hanford, which is 2002, 2004 technology. And that is about as great as you're going to get in a lot of the area.
Yeah, I definitely understand that. In the industrial world in general, it tends to be slow and safe. They want to make sure that what we implement in industrial applications is been proven. So yeah, I understand what you're saying.
well, regular industrial is not near as slow as
It's
the
government.
area. So,
And yes,
but
and they do
yeah.
like the redundancy systems that you've added. Because there has to be like 7 redundancies at least.
Yeah. So Sandran, use this for your senior capstone project, or even a master's thesis if you want to, and you can try and implement the future of industrial automation and bring some of the Hanford people into the 21st century. So you can probably get this project to be an extra credit. You could probably make it, as I was able to get my mechanical engineering professor to work with a master's student that was doing a acoustic measurement in a wind tunnel, putting speakers on wings. So that gave me 2 credits, independent study. You could probably use the PLCNext for an independent study project. So.
And be creative. There's so many different things this
Yeah.
thing can do. Do
Yeah, no, it
something
reminds me a
fun.
lot of C# actually, the way it's laid out.
A lot of what laid out?
And if you're good with C#,
C#,
you can program it with C#.
which, yeah, it's just an offshot of C++ that has its own built-in user interface that you can design yourself.
Yeah.
Much
Gotcha.
quicker for that kind of stuff, which is great for like web pages or simple applications you want to build onto your computer.
But what's happening in the classroom?
Michael says he's still talking, and but we are kind of wrapping up.
Yeah.
I'm not sharing, so I think they're probably just looking at us right now.
Yeah. So, well, let's see. It is 10 after 2. So,
Yeah, we were doing a 1 hour.
yeah. I will get this. I will get this recording up. I'm curious. If you're seeing what I'm seeing, just a -- colon -- but it says I'm recording, so I hope it should show the elapsed time. But Let's see.
So I think we could probably, oh, go ahead, Andrew, what do you got?
Yeah, thank you, Mark. Let me remove my hand there. Hopefully. Okay. Yeah, excellent product. I was curious. We've done these applications again, 1, 2, 3 pumps, shared sequential starts and whatever, number of hours, number of starts per hour, or number of total starts. Excellent product. Is the unit set up in modules that it's set up for 1, 2, 3, 4, or is it a single unit that can handle multiple applications?
In the configuration screen, you can select, 1, 2, 3, or 4 pumps for your application.
Mhm.
Being a pump controller, it's meant to be used on one vessel, up to
Okay.
4 pumps.
Okay. So basically a single set of level inputs, although it could be multiple level points on off. And
Or redundant. You could have redundant sensors as well.
Oh,
and,
sure,
and
sure, sure.
put them right on there.
No,
I've seen
excellent.
floats and radar used together.
No, excellent product.
And
Go ahead, Brad.
and also redundant processors too.
Yes, that was a big plus, what I saw. I saw that as a huge plus. Just one of the things going back years to applications that helped me as a younger person. One of the companies, Brand F, used to have pre-configured applications. I had a bunch of them that were like, let's say you were doing a specific kind of control, and they already had a canned package that would go onto one of their computers, one of their systems. And what I'm kind of seeing here, very similar kind of thing, that, hey, you got yourself 2 pumps, whatever, and so here's your pre-configured system.
And remember, that's just for the pump controller. If you're on the PLCNext web store, there's tons of programs out there.
Precisely.
In fact, I haven't surfed through anything for the power applications, but there might be power programs there as well.
Sure, load shedding, a whole bunch of applications, but level being an interesting one. And when you talk about one vessel, the application that I recall that required multiple pumps was when your rainfall and sump pumps, when your rainfall varied from 0 to 4 orders of magnitude. So things like that. And I'm exaggerating a touch. Okay, thank you so much.
Sandrin's got a question.
Now, I know you said it was able to connect to a server, but could it actually be connected to a server that's in a standalone system? Like it's not connected to the bigger World Wide Web. It's just in an isolated system.
Yeah, standalone PLC doing pump control, no problem. No connection to anything anywhere. You mean you got to open the door and see what it's doing? Yeah,
Yep.
it
it's
would
controlled
run
into it by
forever.
its own special like server rack. You could do that.
I'm sorry, I didn't hear the last question.
It could actually be connected to a standalone server rack. Like say you had your own on-site server rack, you could plug it into that
Absolutely.
one. Okay.
If any, it could be put on any IP network.
Okay. Because Hanford, has HLAN, and a lot of times they have their own special server rack that are physically in the buildings that are controlling stuff. That way, no one can tamper. It isolates it so that no one can tamper with it, because Hanford is still worried about someone breaking into stuff.
Yeah, we don't
For
want a
good reason.
Fukushima in Washington for sure.
Or blow up our or raise the pump speeds to where the motors blow out, and then you have a whole shutdown of the pumping facility for months, and that be a big setback for Hanford because they could do something
Absolutely.
stupid like that.
Well, once again, this already meets all the security the IEC 60341 security. I'm sorry, that's not correct, but it meets the security
62443.
requirements. They're all built into it. It's a standalone controller. It can be connected to any IP device, whether it be a server or a SCADA system. And, I mean, we're Phoenix Contact. We have so many different ways to connect this. Anything from cellular to wireless, Wi-Fi, long distance Wi-Fi, fiber optics, you name it. So many different ways to connect this. But if it needs to be in a secure building with its server, Cat6 cable.
Okay. No, because as I said, when I did the internship, I was actually the guy I was under. I was watching him do their system, and I remember looking over in the corner, and I saw their server rack that was on wheels.
Interesting.
So yeah, and yeah, you could actually see it, and they were controlling everything, and they were monitoring. They had even what was called a blower, which was a process of blowing wind into the air. As the water would fall down, they would blow air into it, and it was able to remove certain particles as it came raining back down. But yeah, there was
Simulated a cooling tower.
not a cooling tower. It was if you agitate air, the water as it falls down, it sometimes can knock certain particles that have been trapped in the water and push it out. So maybe they were trying to get rid of not the chromium, but it could have been one of the higher metals, because one of the systems that they used was really strange, but they had a tower full of wiffle balls, and as the water hit and was being smacked by the wiffle balls, they were actually able to knock out carbonate out of the water using this system. And then they used to use microbials, and then the microbials would eat the chromium, and then they would die and float to the top, and then you would pretty much like a pool, grab up the dead, put them into a container, and then you'd continue just growing the bugs, and that's their whole job, was to eat chromium.
Wow, this is a wastewater treatment plant like no other.
Yes, no, and then they have different zodolites and different things that gets rid of the different radioactive isotopes depending on which one they're trying to remove. They have different sand/zodolites, and they will run through they'll go through a 4-stage filter system. I have, when I was working for them, it didn't have much for me to do, but I was able to look and learn a lot about what different methods they trained. My dad even actually had worked as electrician for them, and he helped when they initially added the bugs.
Wow.
When they first
and then you come along later and it's still working.
They actually had just my first internship, it was still running, and then later I came back because I had to wait after COVID, and I came back out there, and they had just dismantled it because there wasn't enough chromium anymore. It was no longer their main focus, and it was very expensive to maintain the bugs for obvious reasons, because
That's
it'd be like trying to, it's a giant fish tank where these bugs are very sensitive, and you have to keep the right pH and stuff, and keep them happy, or they die.
When you say chromium, you mean the chromium-6, like
Yeah,
Erin Brockovich and her dealing with PG&E.
most likely, yeah, because I know chromium was was a heavy metal that they used a lot back in the day. Same with beryllium.
Yeah.
And I have gone to the 400 area where beryllium was pretty high, and I've actually at the time I was doing the 100 areas were assisting the 400 areas, but I got to go inside the old cabinets that they had borrowed from DNDR because they recycled them for FFTF, which was the fast flux transfer facility. And so they are still a lot of legacy stuff, and that was full of asbestos. They had full asbestos wall shielding still inside the lockers of these, middle school lockers that were just the breaker box room, and it was a full area. It was quite interesting to see, and we had to use a remote plunger system to shut power off to the main breaker, because the person was to shut it off and it were dark, you'd be a black mark on the wall.
Wow.
That plunger failed, and we had to send someone in with a 40-calorie suit with a 7-foot pole to plunge it. And they gave a kind of a rough calculation that they would only maintain 2 second-degree burns at that level.
Oh, well, that's a bonus.
So yes, it's fun when you see because it was this breaker was designed to originally run all of FFTF, and all it's left now is what they call the chlorinator, which is a water treating facility for FFTF that's been around since the 70s. And it's high in beryllium, but they've been keeping this system running for a very long time. But yeah, you can see some of the parts and pieces they have borrowed from different projects that had been shut off.
There you go. Man, this is pretty amazing stuff to hear. I mean,
Yeah.
I've known about Hanford for a long time, but I never heard anybody that's actually been there working on site.
Yeah, my dad was an electrical manager, electrician manager, and he had his own team, and so I got lucky by, he kind of helped put a wig in someone's ear, and I got to see a lot of stuff. I got to see the 90% drawings for K East as they were getting ready to begin the cocooning process.
Wow.
Got to go
So
out
you got any plans to go back?
I would like to. I mean, I tried this last summer, didn't have as much luck. This time I will make sure I talk to my aunts and cousins and get them to, bring my name up so I have a better chance. Because Hanford is a who knows people.
Gotcha.
Well,
yeah,
we can, Ed Vodapest is a lifetime retired Bechtel, and
oh yeah, I've heard plenty about Bechtel.
And so, but your co-op was with Bechtel, or was it with the RL?
I went through a group called A&R. They are just at the end of, as you go down George Washington Way and as you enter Richland, there's a little building, and over in the corner it says A&R Solution Incorporated, and they have an internship program, and so they lent me out to CTC Code the first time, and then I can't remember what the second one was. It was right after they did the swap over, so I might have been something like HMIS. But no, and in fact, Dr. Barb didn't say it, but my first internship back in 2019, I actually was working in the same building as her.
Yeah.
So I actually worked, she wasn't my mentor, Mike Storm was, but there was a total of 3 electrical engineers that I worked with, and I got to do a few projects with her. Because at the time, my dad was the electrical manager who put any and all engineering stuff onto the docket, and they thought, "Oh look, you could use the sun to get projects pushed faster." And that was one of the things my dad was really good at, was getting projects started faster and got them done sooner, because he knew the right people to get projects started and finished.
Well, is your dad active in IEEE or ISA? He's not, because we recognize his name, Linton. But
Yeah. Do you know Todd? It was Todd Linton or Robert Linton.
so
'Cause
no,
he-
I
he-
don't. He's not an ISA member, but
well, I mean, he's passed away now,
oh,
so
sorry.
that's okay. But no,
Well,
he's a master electrician with the local union.
Well, hey,
Gotcha.
apply for the apprenticeship with Michael.
I will. I'll put my name. I need to pick the time and put my name out in many
Yeah.
places
Yeah.
and see what can hit.
Yeah.
Well, good luck to you, Sandra. And it sounds like you've got some great experience so far and a lifetime to come.
And
And
that's the goal.
Use the PLCNext for your senior project here, a real world project rather than a
Oh no,
book
actually,
project.
and if I hadn't found a project, I had a little of an idea to see if someone would like it. Was the idea of making a pipe crawler, which would have been a little kind of RC type design vehicle that would use sonar to map out the map out pipe, like, because you can't physically take stuff and look at the pipe and see the internal conditions, and this would be able to physically run around inside these pipes, hopefully, and record data and then return to you.
Not
You know,
unlike
I-
a pig in the the oil and gas use things called pigs to inspect.
And I was just out in Sacramento, California, and they bought $100,000 drone that they fly through the sewer pipes to do the inspections.
Mm-hmm.
It is a drone in a cage.
The one I was thinking of was, I was hoping that it'd be small enough to get inside 4-inch pipe.
Yeah, little. Yeah, I was thinking what you were talking about was like a littler one.
Mm-hmm.
Yeah.
And what it would do is, the hope would be that it would have flexible limbs and would run on tracks, and so as the pipe would change dimensions, the legs would spread out and maintain contact with 4 parts of the wall. And so it would be able then to squish down into smaller areas as it wanted to travel, because you don't know how pipe would switch, because it could have initially started at a 5-inch diameter and then shrunk down to a 2-inch.
Or it makes a right turn, 90-degree angle.
And I think it'd be difficult to get a human to do that. It might get claustrophobic.
That's a fun idea. That is a fun idea. So.
And that way you don't have to run stuff. Yeah. So depending if you already knew the layout of the pipe, you could pre-program it to do a quick run of there and back.
And so he had the little camera on it.
Yeah, it would have a camera, but I was thinking more using the little echolocation sonars that you can get for the like the Arduinos, and then it could take measurements. But you'd be able to see cracks. They'd be constantly taking measurements.
Well, remember, Arduinos run on Linux.
Yep.
So you can certainly do it with a PLCNext.
Yeah, and that's why, the PLCNext would be an interesting thing. Yeah, no, Linux is a very fun little system.
Well, I always like to point out that the Department of Defense runs on Linux, not Windows.
No, Windows is very easily compromised. I know Apple's a bit better, but yeah, if you truly want something a lot safer, you want something that you pretty much home coded with your own special character system for encryption. And Linux will allow that. I know that much.
Yeah. Well, I wish you the best, Sandra. And one thing that we're going to have to wrap this up, we're a little bit over, about a half hour over time, but I do appreciate everybody staying on the line.
Yep. And thank you.
Once
for
again, I
answering
want
my
to thank
question.
all the colleges, and I want to thank Brad and Andrew too for showing up. So
see, we're down to 6 people. So
we should wrap
what's
it up.
happening in the room?
And everybody's released. Michael gave him a speech, and the room is emptied, and so it's just us here. And time for me to get back to work. I work for Phoenix Contact 8 hours a day. I got another one coming.
What about the trip to Portland for you this
I'm
weekend?
gonna be up in right by Hanford in about 2 weeks. I'm going to Portland, Seattle, Spokane, and back to Portland. So
Yeah.
So all right, I want to thank everybody again, and we'll call it a day for now.
Thank you, Mark.
Take care. Thanks again.
And Brad,
thank you. Hopefully they got all the names of the students.
I asked Michael for a sign-in, so we hope so too.
So okay.
All right. Well, we'll see everybody then. Bye.
Bye.
Bye-bye. Brad, you're on still? Yep.
Stopping recording.
Okay. Yeah, please. That's a good idea.